All right, so it says here that we've got a soccer ball kicked off a cliff with a horizontal velocity of 9 meters per second. The cliff is 45 meters high. How far from the base of the cliff does the ball land? Now, this problem is, I think, a little bit harder than a typical MCAT problem that you're going to see on this subject, but I think it's useful to get used to doing a problem like this, and then the MCAT itself is going to be a little bit easier. So if you kick the ball off a cliff, it's going to move like this, right? And so immediately when you look at that, you think, oh, there's something bizarre going on here. I don't really know how to do the math on this. Right, this is kind of beyond my physics knowledge. And it's actually not. It's actually really easy. So what we do here is we separate the horizontal and vertical movement of the ball, right? The ball is moving horizontally at 9 meters per second squared, or 9 meters per second, right? 9 meters per second, right? That's a velocity. So 9 meters per second. It's not going to slow down horizontally because we can ignore friction, we can ignore air resistance. So the ball is just going to kind of move at that velocity for 9 until it hits the ground, right? Until it is no longer moving. So it's going to move at 9 meters per second until that happens. And so the equation that we want to use here, right? We want to know how far it moves, right? How far from the base of the cliff. So distance, we want to know distance, right? We already know velocity, right? And so the equation we can use is velocity is equal to distance over time. Right, so this is an equation, of course, meters per second, that's velocity, right? And so we just want to know how long the ball is going to be traveling. So velocity is equal to 9, and time is equal to question mark. So we want to know how long the ball is going to be moving horizontally, and that means we want to know how long the ball is going to be in the air. And so that actually makes it a fairly easy problem. We want to know how long the ball takes to hit the ground. And so now we got to do the vertical direction. Now we got to do how long is the ball in the air. So for vertical movement, what do we know? We know that the ball is accelerating due to gravity, so that's 10 meters per second squared. And we know that the ball is at a distance, at a height, we could say, of 45 meters, right? And we want to figure out time. So what equation can we use here? So we can use the equation distance is equal to 1/2 a t squared. So when we do this, we'll figure out time, then we can go ahead and plug time into this equation, right? And so now that we've figured this out, it's, I think, fairly straightforward. There's just a good amount of math, obviously, but so 45 is equal to 1/2 times 10 times t squared. Let me scroll down a little bit so we have more space. And so now let's try and do this in one step. 45 divided by half, that's the same thing as 45 times 2. That's going to be 90. And then divided by 10, that's going to be 9, right? So again, I tried to do that in one step, and I would recommend you do as well. 9 equals t squared. So square root of 9, square root of t squared. Its time is going to be equal to 3 seconds. 3 seconds. All right, so now we've got time. We can go ahead and plug that in here. So now I'm going to erase this, and I'm going to say that time is 3 seconds. Velocity is 9 is equal to distance, which we want to know, over 3. So 3 times 9 is 27, right, is equal to d. And so the answer is 27, right? Now, it's not going to be exact because, of course, we rounded acceleration to 10 rather than 9.8. So typically when you do this, you're just looking for the closest possible answer, right? This is why some of the rounding that we do here means we're not going to get exact numbers. So, but close enough, 27 is equal to the distance. So the distance the ball travels is 27 meters. And so the correct answer is going to be B. Again, this is more of an involved question than you're going to see on the MCAT. I don't think they're usually going to ask you questions that are this difficult. But I did want to show you, the process of how you want to separate horizontal and vertical movements when we're discussing motion for the MCAT. And so that's what we want to do for a problem like this.